This section is all about the composite shapes, the shaded regions that you're asked to find the area of. So there are two different ways to solve for the area of a composite shape. The first is to divide the composite shape up into more easily managed shapes, more manageable, either whether it's rectangles or triangles or squares, doesn't really matter. The first way is to divide the shape up, find the area of each of those shapes that you divided up into, and then add them all together. So there's two ways to divide this shape up. You can either divide it there, or you can divide it there. It doesn't matter which one you choose, so long as you multiplied and added the right things. And I will be doing both, so I can show you can see both ways. All right, so I'm going to divide it here first. When you divide a composite shape, what I would advise doing as the very next step is labeling all the sides that are not currently labeled. So that includes this side right up here, which you can find by adding this side and that side. Because if you were to move this side down, it would be the same length as the side up here. So, and that length is going to be 4 plus 2, which means that is 6. Now, the other two sides that are not labeled, and yes, I say 2 because I divided it up right here. The other two sides are going to be this one, which you already know is 3, and then there's this one, which is 2. So, and yes, you notice I did not have the centimeters tacked onto each of those numbers as is written in the problem, but I did write them in the corner to remind myself so that when I go back with my final answer, I can write the correct units on it. Alrighty, so we have two rectangles. All the different sides have been labeled. So I'm going to go ahead and calculate the area of both of them and add them together. So I'm going to do this one first, and that is going to be the 3 times 6. So 3 times 6 is going to be 18. Next, I'm going to find this area, which is going to be 2 times 2, 2 times 2, which is 4. And when you add those together, you get 18 plus 4 is 22. 8 plus 4 is 12. 18 plus 4 is 22. So 22 is going to be your answer for this problem, but make sure you have 22 centimeters squared. Yes, this is not necessarily a square or one rectangle, but all area is always written with a squared unit. So please make sure you are remembering that. So that is your answer. As promised, though, I am going to show you the other way as well. So if you chose to highlight or to cross them off the other way, this is for you. So if you are going to divide the shape right here, awesome. So I still recommend labeling the sides that are not labeled as your very next step. So there are 3 sides that are not labeled. Yes, I said 3. The first is going to be that one, which will be 4, because I have that. My next, this little segment is going to be 2, because of that side. And then my third one is going to be this long side, which is a combination of that side and that side. Because if you were to move this side over, like there, it would be the same length as this one over here. So that length is going to be my 3 times or plus 2, which is going to be 5. So now that I have labeled all my different sections, I'm going to go ahead and calculate the area of each of them and then add them together. So I'm going to first calculate the area of this one. It's going to be 5 times 2, which is going to be 10. And then I'm going to calculate the area of this second one, which is 4 times 3. So 4 times 3 is going to be 12. And when I add those together, Look at that, 22. So you do get the same answer both ways. You solve it. But just make sure that you are using the squared units to label your answer, please. Alrighty. So let's see if I can move this. Look at that. I can move it. Perfect. Okay. So this one, there are also different ways to solve it. You can divide it up into shapes that are more manageable, like the last one. But I am actually going to show you the second way to find the area of a composite shape, and that is to pretend like the entire area is whole. So pretend like you have a little slip of paper that's this entire area, and then you're going to subtract out the area of this cutout. It's like you took some scissors and snip, snip, snip all the way around. All right. So in order to do that, though, what I'm going to do first is label the lengths of the missing sides. So the first one I am going to label is going to be that top side right there, which is going to be 17. Running out of room. Okay. Now this next side right there is going to be a combination of this one, and this one. Because if I was to move this side over, like there, this would be the same length as that side. And so I have to add up 4, 3, and 4 to get the length of that side. So that is going to be 8, 9, 10, 11 is going to be my side there. All right, so I am going to find the area of the entire shape by multiplying 17 times 11, and that's going to give me 187. And then I am going to go back and subtract out this cutout area, which I can find the area of by taking 3 and multiplying it by 6. So 3 and 6 is 18. Now, instead of adding them, like you would do if you divided the shape up into many little pieces, you are going to subtract these. So when you do that, you are going to have to borrow. So 17 minus 8 is going to be 9. 7 minus 1 is 6. And you bring down that 1 because there is nothing subtracted from it. So your final answer for this problem is going to be 169. And the units are going to be feet squared. Again, yes, it's not necessarily a rectangle or a triangle or really any shape that we can really call it that's a regular polygon. But the units are always squared when you're talking about the area. So that is the only way I'm going to show you how to solve this particular problem, because I really do want you to learn to calculate the entire outside of the figure and then subtract out the cutout, because it is a very useful thing that will save you a lot of time. So we are going to move on to this last problem. I'm going to clear away some of the section. Okay. So in this one, it's similar to the last one in that you want to calculate the entire area of the gray shaded region, and then you're going to subtract the cutout. It's like you had a piece of paper that had these dimensions, and then you took some scissors and you literally just cut it out. All right. So as before, though, I am going to label the unlabeled sides first, just for some clarity. So that side's going to be my 4.5, and then this side is going to be 5. It's a little more manageable for this problem because there are no like missing sides or hidden like inlets kind of thing. I know that's a geography term, but hey, you know, it can apply to math too, right? Okay, so to find the entire area, I'm going to multiply my 4.5 times 5, so 4.5 times 5, and I am actually going to do this up here for you because some of you are still struggling with that multiplication with decimals. So 5 times 5 is going to be 25. 5 times 4 is 20, plus that 2 you carried is 22. Counting up how many numbers are behind the decimal point, and that is the number of moves I make. So my final answer for this particular multiplication is 22.5. All right, so, but I'm not done. That's the entire area. Now I have to subtract out this little cutout. And that cutout can be found by multiplying 3.5 and 2. So that's 3.5 times 2. Okay, and you know what? I am actually going to do this in the same exact spot I did the last one. All right, so I have 3.5 times 2. 2 times 5 is 10. 2 times 3 is 6, plus 1 is 7. I then have to count the number of numbers behind the decimal point, and that is the number of spaces I move. And so my final answer for this one is 7.0. Yes, you can write just 7 because the 0.0 doesn't really mean anything. Okay, so now I'm going to take my entire area and subtract out that cutout. So that leaves me with 5. I have to borrow. 7 minus 12 is also going to be 5, and then that 1 drops down because there's nothing subtracted from it. So my final answer for this problem is going to be 15.5. The units are inches squared. Please remember the units. Please remember the squared part. So yes, 15.5.